Good morning, everyone. I am Rahul Agrawal. Welcome you all for online webinar by IWA Aurangabad Center and MIT Aurangabad. Today we all are here on the occasion to hear DWWT by Dr. Sadgir sir. So we will. I request Vilas Kadi sir to tell us about World Water Day.
Hi and welcome everybody. First of all, I thank the eminent speaker of today's webinar, Dr. Sadgir. Then I welcome all the organizers. Last but not the least, the participants who have participated in this webinar and made it a great success. We are fortunate enough to have this webinar on this World Water Day, which is celebrated on 22nd of March. The second important thing which has to be noted here is that 20th of March is celebrated for this very historical event when Dr. Babasaheb Ambedkar had gone to Mahad for that Saudar Lake, and all the untouchables and the deprived society was allowed to write for water. Secondly, we are also fortunate today today's day is being celebrated as World Happiness Day, as well as India is celebrating World Sparrow Day. So, with all these eminent days being celebrated today, I request Dr. Sadgir to start his speech. Thank you.
Thank you, Kadi sir. Before Sadgir sir start, let's have introduction of Sadgir sir from Shinde sir. So, Shinde sir.
So I welcome all the participants. Today we are celebrating World Water Day. On the behalf of Aurangabad, IWA Aurangabad Local Center and MIT Aurangabad, I welcome you. Today we are having very eminent personality, Dr. Parag Sadgir sir. Before starting the session, I will give the brief information regarding Indian Water Works Association. The Indian Water Works Association is a voluntary body of professional concern and connected with the water supply for municipal, industrial, agriculture uses and treatment and disposal of wastewater. Indian Water Works Association focuses basically on the entire water cycle, encompassing the environmental, social, institutional, and financing issues. IWA was founded in 1968 with headquarters in Mumbai. IWA has 35 centers spread across the country, and all are very active in conducting different activity in the area of water supply and wastewater treatment and disposal. Indian Water Works Association Aurangabad Local Center is established in the year 2005. IWA Aurangabad Local Center is working under the guidance of Dr. Upendra Kulkarni sir, Chairman, Dr. Parag Sadgir sir, COM member, and Kadi sir, Treasurer. And so many active members are with the Aurangabad IWA Local Center. Center has organized so many offline, online webinar and expert talk also to increase the awareness among the student, faculty, and research about different environmental aspects. On the occasion of World Water Day, MIT Aurangabad, in association with the Indian Water Works Aurangabad Local Center, has organized this webinar on decentralized wastewater treatment. So I will give brief information regarding today's eminent personality, resource person, Dr. Parag Sadgir sir. Dr. Parag Sadgir sir has been an environmental engineer, educator, researcher, consultant, lead auditor, environment management, and is working on environment management system ISO 14001:2015 and testing and calibration of laboratories ISO 17025 in environmental engineering science for the last 32 years. Presently, Dr. Parag Sadgir sir is working as a professor at the Department of Civil Engineering, College of Engineering, Pune, Maharashtra State in India. He has worked as a registrar academic, Dean Quality Assurance, and Dean Continuing Education Program in Government College of Engineering, Aurangabad for 6 years. Dr. Parag Sadgir sir is strong engineering professional who completed ME Environment Engineering from VJTI Mumbai in 1996 and PhD in Environmental Engineering from HGS IT and Science Indore in 2007. His research area are water treatment, wastewater treatment, integrated solid waste management, environmental risk and exposure assessment, circular economy and sustainable environmental technologies. He has recognized as a PhD guide of Savitribai Phule Pune University, Pune, and Dr. Babasaheb Ambedkar University, Aurangabad. Under his guidance, 5 researchers has completed his PhD and 5 researcher scholars are working for PhD under his guidance now, currently. He has guided 24 students for MA and MTech dissertation. Total number of journal and conference publications are 132. Such an eminent personality is with us. He also has one patent to his credit. He has worked as an editorial board member of IWA Journal. He is working as an editorial board member of Journal of Chemistry and Environment. Has been executive council member of Indian Water Works Association since 2006. He is chartered engineer, life fellow of IEI, IWWA, IWRS, IWRA, IAH. He is also member of IST, IWA. He worked as a member of Board of Study in Civil Engineering at Dr. Babasaheb Ambedkar University, Aurangabad. Presently, RRC member of Environment Science BOS of the University of Mumbai and MGM University, Aurangabad. He is reviewer of 7 international journals. He has organized 5 national conferences, workshop, and 1 national level IST short-term training program. He has 5 edited books and 1 book chapter to his credit. He has delivered 15 keynote and expert lecture in different area. He has worked as a session chair for 11 national international conference. So today we are having very eminent resource person. I welcome Dr. Parag Sadgir sir. And sir, I request you kindly start your session.
Okay. Thank you. First of all, on behalf of Indian Water Works Association, I'm thankful that we are organizing this event, and the theme for this World Water Day 2022 is groundwater making the invisible visible, because the groundwater is the major important for the rural water supplies, because major water supply schemes are depending on the groundwater, but that is not given that much importance due to the wastewater, untreated wastewater and domestic sewage. We are polluting all the groundwater resources as well as the surface resources. So it is one of the important. So we are choose this topic, decentralized wastewater treatment, on this occasion. So I am thankful to the chairman, Dr. Upendra Kulkarni sir, secretary, Dr. Shinde sir, treasurer, Vilas Kadi sir, Rahul Agrawal, and the other dignitaries present for this webinar. So when we are talking about the decentralized wastewater treatment or the pollution due to the wastewater, overpopulation is the main factor due to which we are facing this particular problem, because every river is having the self-purification capacity, but it is able to purify that particular pollutant up to one limit. And due to the overpopulation as well as the urbanization, the river has lost their self-purification capacity. And presently, if you see any river, we are able to observe that they are polluted one. So degraded water quality, and it is also affecting the groundwater resources. So there are various recent technologies we are trying to use for the treatment of that one. And now it is the new trend is coming from last 10 years that to treat the that wastewater, treated wastewater for the non-potable uses like flushing, floor washing, gardening, agricultural, landscaping, construction, road cleaning, recreation due to the water shortage, so that it will reduce the water pressure on the groundwater withdrawal, allocating room for the recharge. Because if you will observe that from last 50 years, the groundwater level has drastically gone down from 50 feet to 300 to 400 feet. So the treatment and the reuse of the wastewater, about 80% water that reaches to the household use as a waste and pollutes our water bodies and the environment. So we have to reduce, reuse, and the retention. This is the main fundamental principle, if we will follow, then we are able to, we will successful in reducing these particular pollution and to conserve our groundwater sources. In the reduce, we have to reduce the fresh water demand in the agriculture. If we use this treated wastewater, obviously it will reduce the demand, fresh water demand. Reduce the fresh water demand in the industry. Similarly, if we will reuse the wastewater, treated wastewater, it will also reduce the fresh water demand. Reduce the fresh water consumption by the household. Practically, when we say, we are saying that for the urban areas, we require 135 LPCD, liter per capita per day. Out of that, 40 to 45 liter is only we are required for the potable purpose. Other purposes, whatever we are using, they are other than the potable, they are non-potable purposes. So for that, we can able to use the properly treated wastewater, then it will reduce the fresh water consumption. And similarly, we have to reduce the water pollution. The reuse, grey water reuse is also, we have to think, black water treatment and the reuse, ecologically water purification through the natural process. Then retention, upstream investment in the natural infrastructure, like wetland and the forest. Water storage project like above groundwater reservoir and the rainwater harvesting. Underground aquifer storage, recover activities. Increase the water retention of the soil so that the agricultural will need less quantity of the water. So the major factors which are affecting the wastewater system is the population growth. Urbanization has changed from 48% to from 28% in 1947 to now it has increased up to 48%, and the day will come when it is more than the rural areas. So, and instead of urban and the rural, peri-urban population is increasing, which are having the scarcity of all the facilities, just like the wastewater treatment or the proper water quality. So wastewater composition, discharge, and the enforced effluent standards, they are also now NGT. In the last year only, the National Green Tribunal has changed the effluent water quality, effluent wastewater quality from 20 mg per liter to 10 mg per liter. They are stringent the standards so that we are able to maintain the water quality of the rivers. The demand for the effluent, urban and agriculture reuse is there, location, required qualities, and the potential quality are there. So the typical composition of the untreated domestic water, it contains main factor is the BOD 220 mg per liter, and total solid is 720 mg per liter. Other nitrogen, nitrite, phosphorus are there. And if we see that as per our standards, now we have to reduce the BOD to 10 mg per liter. Means it is a Hercules challenge to remove or reduce the 210 mg per liter. From every liter, we have to reduce 210 mg. And similarly, the suspended solids from 220 to, again, it is 210 mg per liter. Coliform quantity is also high. That also we have to make when we are talking about the reuse, we have to remove all these coliforms. So in the conventional treatment system, we are removing organic matter, nutrient, that is eutrophication, fish kill, order problem, space requirement is more. So up till now, for the urban areas, we are using the centralized wastewater systems. So it is having the approach, we are collecting all the wastewater from all over the area, transporting that one. So whatever our wastewater system means, drainage systems are there, or drainage schemes are there. Out of that, more than 65% we are providing that amount for the transportation of the waste only. The treatment part is 25% only. So instead of in the decentralized waste, if we will talk about the decentralized wastewater treatment, we are able to use the efficient treatment for the daily wastewater flows up to 1000 meter cube or 1 MLD. Now we can go up to 5 to 10 MLD also by using the proper methods. They are tolerant toward the inflow fluctuations, reliable and long lasting. Maintenance of the sewerage system is easy here, and low maintenance cost is there, and expensive sophisticated maintenance is not required. So quality of the treatment is more efficient than the traditional system. Treated use can be effectively used within the sector. Groundwater recharge is also possible. Less investment is required as compared to the major one. System construction results in less environmental disturbances, and the system expansion is easier. So, in short, decentralized means if for the small area we are able to provide the treatment plant. Means if we talk about any urban area, everywhere we are providing 10% space reserved for the garden and all that thing. So these decentralized wastewater systems we are able to provide in the garden area only. And on the top of that, we are able to provide the gardens. So it will help to that by using that particular water for the gardening also, as well as for the road and the other purposes like construction and all the other things that we are able to provide. Only the disadvantage is that large area is required as compared to the quantity. There are, if it is not properly treated, there is potential threat to the groundwater quality. No dilution benefit is there. Risk of failure is the concentrated in that particular area. It required great awareness, participation of the stakeholders. It is less familiar to the engineers. Funding challenges are there. Lack of management structures, fragmented regular structures, and policies are not that much finalized up till now. The government is trying to make the rule and regulations for that one. And in the thickly populated area, it is difficult to get the site for the STB because everybody want to treat the waste, but not want the STB in next to him. So that is the problem in the urban areas for the decentralized wastewater treatment. So various technologies we are able to use are activated sludge process, extended aeration, membrane bioreactor, moving bed biofilm reactor, sequencing batch reactor, a flow aerobic sludge blanket, waste stabilization pond, constructed wetlands, biotowers, anaerobic buffet reactors, then package treatment plants, and the ABGS purifier. So in the very popular is activated sludge process. It started in 1918 in England, and afterward they have done the various modifications in that also. So if we talk about the activators, this is the aerobic biological sewage treatment. In this particular, there are two types of systems we are using in the secondary. In the preliminary, we are taking the screen, grid chambers, skimming tank, and in the primary, we are using the primary settling tank. And in the secondary, we are having various options. In the biological, there are two options, means one is attached growth system, second is known as a suspended growth system. The activated sludge process is the suspended growth system. So in this, we have to supply the oxygen, and it is having the large electrical energy is required. So normally afterwards, whenever we are in the for the municipal corporation, municipal council, they are trying to reduce this particular electrical consumption, and they are not using that one. So we are not able to get the required quality of the effluent at the end. It is advantages if it is properly maintained, if properly used, it is having the good effluent quality. Process requires small area of the land, removal of the BOD and bacteria are around 90%, low cost of the installation. Disadvantage is that sudden change in the characteristics will adversely affect the quality. Operating cost is high. Certain type of industrial waste may causing the sludge bulking, and the effluent skill supervision is required. Then extended aeration is there, that also we can use. Then nowadays, which is popular one is the membrane bioreactor. It required less space, and it is activated sludge process with the membrane separation process. We are able to see in this particular. We are immersing the membranes in this one, and the reactor is operated similar to the conventional ASP, but without the need for the secondary clarifier and tertiary treatment steps like sand filtration. So we are using the low pressure membrane filtration like microfiltration, ultrafiltration, and used to separate the effluent. Then in this membrane bioreactor, we are using technology, we are providing the membrane, and it is obstructing these pollutant to travel on the other side, and it is cleaning that one. Advantage is it eliminates the secondary clarification, high volumetric loading, shorter HRT, hydraulic retention time, and lower volume is required. Longer SRT, that is a sludge retention time, and less sludge is produced. Operating at the low dissolved concentration, and there are potential for the simultaneous nitrification, because nowadays the limit is given for the nitrate also 5 mg per liter. So it is necessary to treat that also. So the high fluent quality, we are able to get 95% COD reduction, 98% BOD reduction, 99% suspended solid removal is there. Less space is required. It is suitable for reuse after following the disinfection and the other treatment. Disadvantage is high capital cost, limited data on the membrane life. So we have to change the membrane after a certain time. It is high cost of the membrane replacement is also, and energy cost is there. So normally we are using two type of the membranes. One is hollow fiber, another one is the plain membrane. Then we are used after MBR, we can use the alternative is the MBBR, that is the moving bed biofilm reactor. So in this particular tank we are putting that one. This is the combination of the extended aeration as well as the floating biological reactor, means suspended and attached growth system. As in the trickling filter, we are using the attached growth system. So that is used, that particular technology. This combination is made in the MBBR, that is a moving bed biofilm reactor. So this is, we are using biological fixed film process, floating, and media retained in the aerator. So this is the combination in the aeration tank. In the ASP process, means aeration tank only we are putting this plastic media, and it is increasing the efficiency of that one. Advantage is that higher SRT, which is favorable for the nitrification. It responds to the load fluctuations without operator's intervention. Lower sludge production, less area is required. Resilient to the toxic shocks. Disadvantage is it is manual bacterial monitoring required. The operator is needed, and some insects may be get attached. Now again, due to the NGT has done the modifications in these particular effluent standard, that is from 20 to 10 mg per liter, and nitrate 5 mg per liter. We are municipal corporations and the municipal councils are trying to change or to modify their existing sewage treatment plant or the ASP into the sequencing batch reactor, because in the same construction they are able to double the capacity due to the increase in the populations. Nowadays this is the problem, and as the population increases, urbanization increases, land availability is very less. So in this particular, we are providing, first we are filling the tank, the particular compartment, then we are providing aeration for the particular period. We are allowing to settle and decanting that one. This is a batch process. So in these particular field, react, settle, and decant, we are able to treat the wastewater. So difference in between these two technologies is that SBR perform equalization, biological treatment, and the secondary clarification in the single tank. Means in the same aeration tank, we are able to provide these all using the time control system. So advantage of the SBR is it is equalization, primary clarification, biological treatment, secondary clarification. SBR requires the small space, and it is a controllable reactor time, and it is having the minimal footprint, high nutrient removal capabilities. BOD removal efficiency is 85 to 90%. But the limitation is that it requires higher level of the sophistication. Like if we want to provide this automation, then the sensors and all that cost will increase. Higher level of the maintenance is required, and the potential plugging of the aeration devices also a problem. Then UASBR is there, that is the anaerobic process that is used for if we want to produce the energy by collection of the biogas. Nowadays, these Praj industries and other industries, they are develop the model so that by using this particular, they are able to produce the electrical energy as well as the CNG also. That is the compressed natural gas. And up till now, the concept was that to whatever we are doing the wastewater treatment means we are wasting the money, because that municipal, that our local bodies are not getting any return from that. But by using these particular technologies like UASBR, they are able to get some returns by in the terms of the electrical energy or like CNG. So due to that, it is getting more popular day by day. So advantage of the UASBR is it produces easily dewaterable excess sludge, low energy consumption, absence of the noise and the odor nuisance. It is the proven technology. Low initial investment and maintenance cost. Methane-rich biogas production is there. And it is production of the enriched nutrient sludge, which can be used as a fertilizer. Longer startup period is there. That is a disadvantage. Lower performance at the very low loadings. And it is difficult to maintain the UASB because we have to maintain the pH, alkalinity, and the temperature at the proper. Then only these methogenous bacteria are able to produce the maximum efficiency of the biogas, means methane gas. And we have to provide the separators also so that we can collect the methane gas separately. Then in the decentralized treatment, we are able to use the root zone treatment. If the land available is more, then this type of the treatment is preferred. It is the natural process. No mechanical, no electrical part is there. Its retention time is more. It is settling anaerobic buff. We are doing the pre-treatment, then anaerobic buffer reactor, anaerobic filter, and planted gravel filter. There are advantages comparatively. Capital cost is less. Construction bed is simple. System require little or low maintenance. It is a robust process. It is able to withstand. It gives the consistent quality of the treated wastewater. Limitation is that highly advanced treatment is required for the larger area, and knowledge of the nature treatment know-how it is difficult to design for the unknown effluent. For the domestic sewage, we are able to make that one. Possible problem like steep topography, shallow soil, it's again depending on the infiltration rate of that particular. Then we can use the constructed wetland technology also for that one. There are again 3 types: in surface, subsurface. Subsurface, C is subsurface, surface. Then in College of Engineering, Pune, they have actually implemented this particular technology, that is the Navatech DST supported project for this one. And this is the anaerobic system as a gravity flow system, which does not require pumping. They are provided this vertical flow wetland of capacity 140 meter cube. And treated wastewater is we are using for the gardening as well as the flushing in the hostel blocks. User-friendly, low cost operation and maintenance, consistently in the treatment performance. It is established in 2016. So now 5 or 6 years is there. No skilled operator is required, no chemical required, no electricity is required. Then I have developed one technology that is, we are given the name that is the ABGS. We have got the patent for that. And in this technology, we are using particularly these components, that is the equalization. We are using these medias which are locally available, that is the brickbat, grit, sand, and the charcoal. So, and plants like Canna indica, and aeration is done. So in these particular, we are able to use brickbat, sand, hydro plants, coconut coir, neem coal, grit. We have tried these various media, and then we have found out that brickbat and sand, and with it is giving the good results. So this is the pilot scale model we have, and we are able to get this quality. You are able to see in the picture. This is the actual pilot plant we have established in College of Engineering, Aurangabad. And there you are able to see, this is the picture. This is the actual effluent quality. And afterwards, we are getting this effluent quality. The same system we can able to use for the nalas or the streams or the small rivers, so that we are able to purify that particular water, wastewater. So these are the results what we have. We have found out. This work is done by Mr. Agrawal in his PhD work. BOD removal is 89%, COD 90%, total suspended solid 85%. So like that, we are able to get the good results in this particular. And the operation and maintenance also, after 6 months, we have to only, whatever the waste we have removed from these equalization tank as well as that, we are able to form the bricks, and the bricks we have to wash only after 6 months. And again, we can reuse that particular. Similarly for the grit and sand also. So less energy consumption due to the gravitational flow. It is, we require only the 0.5 HP pump, that is the electrical energy required. No mechanical part is there. And whatever media required, it is locally available. Area requirement is also less, that is 0.05 to 0.08 meter square per person. Land requirement, order free, evergreen aesthetic environment is there. And treated wastewater, treated water is suitable for domestic purpose like gardening and other than the drinking purpose. The performance is compared with these all. So though it is removing in the primary and secondary, we are removing 90 to 99%. For the, if we want to reuse that one, for it is necessary to tertiary, give the tertiary treatment. In the tertiary treatment, we have to give the coagulation as well as the solid and liquid separation. Disinfection is required. So we are using filtration, flotation, and the adsorption. And disinfection is done by chlorination, ozonation, and the UV disinfection. So in these, whenever we are using, we can use the separation is that if suspended or the solids are having greater than 0.5 micron, then we have to use the microfiltration. If it is in between 0.1 to 0.01, we have to use the ultrafiltration. If it is 0.01 to 0.001, we have to use the nanofiltration. And it is less than 0.001, then we have to do the reverse osmosis. So depending on the that solid size, we can select the particular which filtration is required. This chart shows that which treatment and when we have to give. So for this purpose, actually, this is the picture from the Mahabaleshwar. In the Mahabaleshwar Municipal Council has established this tertiary wastewater treatment plant for 1 MLD. They have given these activate. They are having SBR. After the SBR, they have provided. This is the sand filter. After the sand filter, the wastewater goes to the ACF, that is the activated carbon filter. And after that, they are giving ozonization. This is the ozone system. And after that, it is here you are able to see this outpost from where they are giving to the tankers. And that tankers are supplying these particularly for the construction purpose or for the hotels for the other than drinking purpose, like flushing and all that. So this is actually implemented. They are implemented for 1 MLD and another at another place also 1 MLD. So 2 plants already they are established in Mahabaleshwar. They are started using and they are getting good quality of the wastewater. And the outlet quality you are able to see here. That is 5.5.9. In between these one, BOD is less than 10 mg per liter, COD less than 50 mg per liter, suspended solid less than 10 mg per liter. Ammonical nitrogen is also less than 5 mg per liter. Total nitrogen is less than 5 mg per liter, and total coliforms are also less than 100 MPa. So when we are selecting the technology, which technology we can use, we have to cost, operation and maintenance, advantage, disadvantage, relative cost, and cultural acceptability and suitability. So we have to think about these factors. So whenever we are thinking that one, what is the quality treated, what wastewater quality we require, what is the power requirement, what is the land requirement, what is the capital cost available, what is the O&M we are able to give, what is the maintenance requirement, how we are able to maintain that one, and operators' attention, whether is it easy to understand or not, whether it is reliable or not, resource recovery is there, and the load fluctuation, whether it is able to withstand for the load fluctuations or not. So this is one survey done by the ministry, our government of India, and they are given the guidelines for the decentralized wastewater treatment by using this technology, that is the ASP, that is the activated sludge process. EA is the extended aeration, MBR is the membrane bioreactor, MBBR is the moving bed bioreactor, SBR sequential batch reactor, UASB, that is the flow anaerobic sludge blanket, plus ASP is the waste stabilization pond, and CW is the constructed wetland. They are given the quality, qualification, and all that. And most important is that, which is not available in any book, that is these cost for the various technologies. And what are we are getting? Performance after the secondary treatment, what we are getting in the ASP, what we are getting in the MBBR, SBR, UASB, again MBR. So as per the present norms, we are able to get only in the SBR and MBR. So in these particularly, if you talk about the capital cost, in the capital cost, we are able to see that ASP, MBBR, SBR, and USB, it is similar to each other. But in the MBR, it is the 5 times more. WSB is the half of the ASP. So this is the average capital cost we can talk. And area requirement is, it is average area requirement is 900 meter square per MLD. And for the MBR, it is half. For the ASP, it is more, and for waste stabilization pond, it is 6 times of the ASP. Then if you talk about the O&M cost, energy cost, we can see that for the ASP, we require 180 kilowatt hours per day per MLD. But for the MBR, it is required 300 kilowatt hour per day per MLD. Similarly, if we talk about the tertiary treatment, so daily power cost, if we will take the cost as 6 rupees per kilowatt, the cost required is rupees 46 per MLD per hour. So including the standby power cost. So yearly power cost is 4 lakhs per MLD. Means if you are treating 100 MLD, your cost goes to 4 crore rupees. And that is the major cost. If you took the MBR, you require 7 crore rupees. So 3 crore is your increase in the budget. If you talk about the WSP, it is only half crore rupees. So all these factors we have to consider. The repair cost is given in the comparative. Chemical cost is acquired. That is also 5 lakh to 6 lakh rupees per MLD. Manpower cost is roundabout, it is per annum, it is round about 6 crore rupees, it is shown. So when we talk about the total annual operating and maintenance cost, it is round about 6.29 lakhs or 6.6 crore rupees per annum. So present treatment cost, if we will talk about that per paisa per liter up to secondary treatment, it is 0.32. And that's around about 0.32. So these are the references for the various guidelines and all that. Thank you. Okay, over to Shinde sir. If any questions are there, you can unmute yourself and you can ask.
Thank you, sir. If any questions, participant can unmute themselves and can ask the question. Yes, anyone?
Hello, sir.
Yes.
Kausalya here.
Yeah.
Morning, sir. Sir, what can we think about this topic regarding village wastewater generation?
Wastewater treatment, village wastewater treatment.
Village wastewater treatment. Sorry.
In the village wastewater, we can easily, depending on, as we have discussed, that capital cost available and skilled manpower available. You can select the which technology you can implement that one. It's starting from the MBR, that is the membrane bioreactor, and to MBBR, it is not that much efficient. But you can apply these your root zone technology or that ABGS purifier, whatever I have told. We are trying to implement that for the rural area also. So they are in the rural area, we have to see that which is not having the mechanical, electrical energy is required or any part is required, because it is very difficult to maintain that systems afterward. Once implementation is okay, but afterward for maintenance, it is very difficult. So we have to select the technology which is possible to implement at the rural area by the local bodies available. So that factor is more important in that particular, because electrical energy means electrical fluctuation is very high, load shedding is there, and if we have to supply the chemicals from the city, it is also when it is not, we cannot assure that there is a proper supply at proper level, means at particular timing. Okay.
Oh, okay, sir. And if we, this is just my thought. If we, introduce demand side management with this, can the load on total system decrease and efficiency will increase?
Naturally, if we will implement these reuse, means out of that nowadays, as in these particularly whenever the large in city areas normally, if you are having the larger township, then they are implementing that for these. You have to treat your wastewater, and you have to reuse that for the flushing purpose and the gardening purpose. That is mandatory done. So similarly, if we are able to implement that, unfortunately, only Gujarat and some states has implemented reuse wastewater policy, and the other cities as well as the municipal council and municipal corporation has to implement these or adopt the grey water reuse as well as the wastewater reuse policies, draft rules and regulations in there. They have to sanction that one, they have to implement that one, then only this is possible, if they made it mandatory in their
Yes,
rules.
sir. And in that way, it is a demand side management.
Yes.
Yes. Thank you very much, sir. It was a very good session.
Okay.
Thank you.
Sir, I need some information regarding natural coagulant. What are the different natural coagulant are feasible in rural area?
In the wastewater or water?
In the wastewater, sir.
You can similarly, you are able to use that one, which is available in the nearby area. Like you can use the moringa oleifera also. But for these wastewater, coagulant is not that much required. You can, if you use these particular, whatever the locally available material is there, because your aim is to reduce the organic matter, that is the carbonaceous organic matter as well as the suspended solids. And these suspended solids are having the specific gravity such that it is easily settles. Only organic matter, you have to change the complex organic matter into the simple organic matter, and that is done by these bacteria. So if you give them sufficient time, they will convert that one.
Okay, thank you very much, sir. Thank you. Rahul, you may proceed.
Okay. I request Rashmita ma'am for vote of thanks.
Yes, Rahul, thank you. So on behalf of IWA local chapter Aurangabad, I would like to thank our speaker of today's webinar, Dr. Parag Sadgir sir, who has spared his valuable time on a very short notice Sir, in a nutshell, you have really briefed us how decentralization of water can be done, the methodologies, the pros and cons, the factors to be considered, and how economically it would be viable for different cultural demand also. Sir, we are really thankful to make this complex problem in a very simpler way, and I really appreciate this because your research work also has contributed to this presentation, and it was really appreciable, sir. I would also like to thank our chairman of IWA local chapter, UD Kulkarni sir, the secretary, the treasurer, all other members, Dr. Sunil Shinde sir, Rahul Agrawal for the technical support. And finally, not the least, that is all the participants and students for their patience listening. Thank you so much, sir.
Thank you. I also thankful to Dr. Mr. Hanmantachari for attending the session, and Dr. Upendra Kulkarni, as he is not able to, he is in the traveling. So thank you for this Aurangabad Center. Thank you.
Thank you. Thank you very much, sir.
Thank you.